Hello everyone, this is Neil Mitra. I'm a specialist ASA for IoT. Welcome to the first ever Tech Talk of 2020. Wish you all a happy new year. So now you are here, I assume you are connected to the smart home or the IoT industry or the voice industry in some way. So either you were a manufacturer, you were a supplier, you were an OEM, a partner, or just a developer who wants to build the next gen of voice solutions. So this session is perfect for you because here you will learn how using Alexa voice services and IoT services, you can build the next cool voice product. I really love the fact that technology has brought us to a point where billions of people have a voice and each voice can be heard and be acted upon. This is a 300 level session, so I assume that you have basic familiarity with Alexa voice services and AWS IoT services. In case not, fear not. We'll start with a quick refresher. For Alexa voice services, you will learn how microcontrollers with less than 1 MB of RAM can run Alexa now. For IoT, you will learn how to build, manage, and operate all these voice control devices securely at scale once they're on the field. We'll also talk about some real-world design patterns that will help you understand how to use Alexa services and IoT services in conjunction with each other. We'll share with you a reference architecture. We'll talk about the pricing. We'll tell you how to get started. And I'm not letting you go until I show you a demo. So, Alexa voice service. If you think about it, voice has fundamentally changed the way we interact with technology today. And Alexa voice service is the brain of any voice product that has Alexa built in. So if you think of the Echo family or any third-party products from LG or Sonos or Bose or Vizio, they all use Alexa voice services. And I am amazed how even non-tech savvy people like my mom, right? She's still not comfortable with laptops and tablets, but she can have a natural conversation with Alexa to turn on the lights and lock the doors and whatnot. So if you use Alexa, have used Alexa in some form, you might know there are two categories of Alexa devices. There is one Alexa built-in device, and there is also companion devices that works with Alexa. And this is really funny that my mom is curious, like why she has to go to that Echo device every time to turn on the lights in my bedroom or other rooms. Why she can't talk to the light directly? And that's a very valid question, right? So let's see why. So when you say Alexa, turn on the light, what really happens? There is a wake word engine that gets triggered, the speech gets captured through the microphone, and the user utterance is sent to Alexa Voice Service API onto the cloud. Now, within Alexa Voice Service API, there are various engines. The first one is a speech platform, which acts as the orchestrator for all the requests, that is also referred to as events, and the responses, that is referred to as the directives. So once the user utterance reaches the speech platform, the first thing it does, it invokes the automatic speech recognition engine. So the audio waveforms are converted into text. Then the speech platform refers to natural language understanding engine to infer the intent of the user utterance. And once the intent is understood, the respective skills get invoked. So for example, I use Philips Hue. So once the intent is understood, the Philips Hue skill is invoked and the response is received, which is converted from text to speech using a text to speech engine, and it's streamed back to the device as an audio wave again, which is played through the speaker. That is cool, right? So now let's also talk about the device side, because this session again is more focused on the developers and the device manufacturers who are going to build all these devices. So it's super important for you to understand what is really happening on the device side. So firstly, all Alexa built-in devices need to have a device SDK, which is a C++ based SDK. And once there is a user utterance, there is an audio signal processor on the SDK that picks up all these utterances and pushes it to the shared data stream. Think of shared data stream as a temporary buffer that pulls in all this audio data and keeps on discarding it. Then there's a wake word engine, and the wake word engine is constantly examining that buffer, and it examines if the trigger word Alexa is invoked. If yes, then it triggers the audio input processor to send all this audio data to the cloud using something called Alexa Communication Library. So think of this library as an orchestrator for the edge. This is responsible to send all the events to the AVS cloud and also receiving back all the responses or the directives from the cloud. And once it does that, there are a lot of things it needs to do. It needs to send all these directives to something referred to as Alexa Directive Sequencer Library. Because think about it, there might be a lot of different things happening on your Alexa device. You might be streaming music. At the same time, you might have a lot of reminders that needs to be pushed back to you, and you should be notified. Also, there can be someone on the door, and the live feed from the door might also come to your Alexa device. So there is a need of sequencing all these different kind of directives. And then you have the capability agents, which are essentially all these different components that I discussed. And finally, there is an active focus manager library, which does all this interrupt handling and does the prioritization to figure out which interaction gets a focus on the media player, and then it gets played back to you. So you can see there is a lot happening, both on the device side and also on the cloud side, but the user experience is super low latency, right? This is incredible. And I remember a quote from Steve Jobs, where he said that it's really, really hard to do something very simple. And this is one of the perfect example of that. So coming back to my mom's question, like why she needs to talk to the Echo device again, right? Why she can't directly talk to the lights or the switches, and why can't you do it today? There are a couple of reasons. Smart home devices like the bulbs and the switches are built with low-cost microcontrollers, and they have a very limited compute and memory, which could be like up to 1 MB of RAM or less. And the current AVS device SDK that you just saw, it needs at least 50 MB of RAM and a Linux-grade device, which our customers and the partners who are building these products cannot afford, because that leads to high engineering bill of materials cost. And that will eventually also increase the MSRP of the product that goes into the market. For example, I don't want to buy a $100 bulb or a switch. I would like it to be much cost effective. The next thing is Alexa is continuously evolving. We're continuously listening to your feedback and working backwards and put all these features and capabilities into the Alexa devices. Now, let's say you take this device SDK and you wanted to build a miniature version of this device SDK that fits your purpose, where you can still run Linux in some way in all these resource-constrained devices. But then you are increasing your engineering cost, because now you have to have engineering skill in-house. And you have to always play this game of catching up with AWS, because we're continuously evolving our Alexa capabilities. And also there is post-launch complexity if you do that as well. So you asked us, right, AWS, what can be done to solve these problems? How can you help us? So our engineering team had been working very hard on these problems, and I'm very happy to tell you that they finally cracked this problem. So they figured out that if we can offload a lot of the compute and memory intensive operations that is happening on the device SDK now to the cloud, but still keeping the low latency experience that is required for the great customer experience, this problem can be solved. So what we did, we recently launched this new capability called AVS Integration for AWS IoT Core, short named AIA, which will offload, you can see the steps from 3 to 6 to the cloud. So now on your device could be super lightweight. It still have the wake word engine, because for privacy reasons, we don't want to hear anything from you if you don't say, Alexa, do this and do that. We are only going to hear you only use an Alexa command. So the wake word engine still needs to stay local. The shared data stream needs to stay local, but everything else, all the media decoding, all the buffering, all the heavyweight processing can now happen on the cloud. Great. So this is how the architecture looks like, and we will dive deep into each of these components as well. So you can see on the left, you have the Alexa device. That is where you have the reference client SDK now. And it communicates over MQTT, which is also a very lightweight protocol. The next thing is Opus. It uses a lightweight media protocol because in a traditional AVS device SDK, you have to deal with a lot of other media codecs, and that also causes a lot of compute and memory. And finally, you need some kind of buffering because you need to sequence all these directives and play back to your users. And then on the cloud, AWS IoT Core came into the picture because that does all the magic of all these capabilities that is now offloaded to the cloud to the Alexa IoT Service APIs, which eventually talks to the Alexa voice service, but everything is seamless for you. So let's now go back to all the problems that we had and see how they're solved with this approach. The first approach is, if you think about the Alexa experience, there are two different experiences, right? One is the tap to talk, and the other one is the far field voice pickup. So for tap-to-talk devices, it's really easy because now you can use a AWS IoT SDK, which works over MQTT. You implement Opus that I mentioned, which is also an open source library. You do some kind of audio buffering at the edge, and then there is an authentication mechanism that needs to happen for the security and privacy. And for far field devices where you want to play music and talk over music, you need certain added capabilities as well. So that's where you need different kind of audio algorithms. So you need the wake word engine, and you have to decide like what kind of hardware I'm going to use. But irrespective of which use case and which experience you choose, both of these can now run on microcontrollers with less than 1 MB of RAM, which is kind of amazing. So that helps you to reduce the cost, and that also helps you to simplify the firmware integration because we are going to give you the device SDK that you can put on your device. So what about the device hardware? I keep on talking about less than 1 MB. So again, based on the experience, if it's tap to talk and then you have to do the touch initiated, you can use an ARM M4 processor with even 500 KB of RAM, you will be good to go. And the underlying operating system is Amazon FreeRTOS, which is the operating system for microcontrollers. The connectivity is using MQTT over Wi-Fi. And if you need more advanced device like a wireless speaker, right? That's where you use something like an ARM M7, and you need at least 1 MB of RAM probably based on the use cases you're trying to support, but you still run FreeRTOS. But you still have access to the AVS device SDK. You might have wireless speakers, which are large devices and can run Linux and can run 50 MB, and where you do not have that restriction of having a reduced hardware and reduced cost. So that option is still there for you to use, but at the same time, now you can work on more use cases to improve the customer experience. So in today's discussion, we'll primarily be focusing on this new capability, which is Alexa voice service integration with IoT Core, also referred to as AIA. So I'll be using both these terms interchangeably in the rest of the conversation. Okay, what else? Traditional AVS clients needs multiple connections for the music and the alarms and the speech and the authentication, versus here, since we have to reduce the memory footprint and the compute footprint, there is only one persistent network connection, which is great. There's also one codec on the device, as I mentioned, which is Opus, versus if you have to have multiple codec support like AAC or MP3 or anything else, that was very compute intensive and we had to offload that to the cloud. There is also one speaker stream versus multiple for media mixing. Example, if the music is on and the alarm starts playing, which stream gets a priority? That problem doesn't exist anymore because it uses a single stream at this point. In terms of authentication, with the traditional AVS clients, it needed to do hourly token refreshes with the AVS cloud. But now, since we have AWS IoT Core in the picture, all these back-end refreshes is being managed by IoT Core and the services that we have developed on the cloud. The only thing you need to do is to initially do an authentication during the registration of the device, and after that, voila, we take care of everything for your token refreshes. So that is cool, right? So one of our customer is iDevices, and they're the first one to use Alexa voice service integration with IoT Core capability to launch their switches, which is available in the market now. And they had been working with us very closely. And if you can see on my right, this is what one of the iDevices switch looks like. So Alexa, play some music.
Here's a station you might like. Maroon 5 on Amazon Music.
That's great, right? Alexa, tell me a joke.
Did you hear the secret about the turkey?
No.
It's really juicy.
Alexa, turn on the light.
Okay.
Alexa, play Baby Shark.
Baby Shark by Pink Floyd on Amazon Music.
Like it? So you see, Alexa, stop. So you can see that the experience is still pretty similar to a big Echo device. And that's the engineering that went under the hood with the microcontroller. Alexa, turn off the light.
Okay.
So now my mom doesn't need to go to the Echo device every time. She can just talk directly to the switch. So let's move on. So now we have done a quick recap and dived a little deeper on the Alexa voice service. We learned about the different kind of SDKs that is available to you. We learned about the different experience that you can create for your customers. Let's talk about the IoT services. Like, where does IoT comes from, right? Obvious question. So once you build all these voice-enabled devices, at the end of the day, they're still connected devices. So this switch, these lights, they're all smart, but at the end of the day, they're a connected device that can be there for years in our home, right? I don't want to replace my switch every 1 year or 2 years, right? It will be there for maybe 10 to 15 years. Same thing with the lights. I probably don't want to replace them for next 4 to 5 years. So how do you ensure that your devices are not only deployed securely, but organized and managed throughout their entire life cycle? So that's where IoT services comes into the play. And we have built different services across the device layer, across the control layer, and the data layer in the last few years, working backwards on your use cases. But this session is not about diving into all of the services. We have a lot of different webinars for that. We have YouTube videos from reInvent and other events. In this session, rather, we'll talk about different design patterns that leverages some of the services marked in amber so that you can understand how these services in conjunction with Alexa voice service can help you manage your fleet. So we are going to first talk about the device layer. So this is where you provision your devices and connect your devices and make it available for the consumer market from your manufacturing facility. Then we'll talk about the connectivity layer, where you essentially organize and manage and secure all these devices through their entire life cycle. And there's also the analytics layer. This is where you collect all the telemetry data, events data, operational data, but we won't have a lot of time today to touch upon that. So we are essentially talk about the two layers, device layer and the connectivity layer of this IoT virtuous cycle. So let's get started with the devices layer. So let's think of this scenario, right? You are a manufacturer and you build all these smart switches and light bulbs, and you have decided that you are going to use X509 certificates for TLS authentication. So what you'll do, you will generate all these certificates using IoT Certificate Authority, or you can bring your own certificate authority if you have an investment in that. You will create a provisioning template, which essentially helps you create all the different resources like the IoT things and the IoT policies and the IoT certificates, which is necessary for the IoT device to securely connect to the cloud and being operational. You'll also have a parameter file. This is essentially your input file to the provisioning template, where you provide all the different device metadata. And finally, once the workflow is triggered, it creates all these different resources that you can see on your screen. The things group, the certificates, keys. And once you have that, you essentially download all these keys and certificates. You send it to your OEM, or if you're the OEM, you essentially send it to your manufacturing production line, where they get embedded on the devices like these bulbs and switches that will eventually go out into the market. So once that is done, taking a step back. So this is how a parameter file looks like. So this is where you provide the name of the thing, the serial number, the certificate information, and then there's a provisioning template that you can see on the right side of the screen. This is a template that you use with AWS IoT service, which helps you to create all these devices at scale. So now you have created your voice fleet, right? It's there. It has all the certificates and keys that it needs to talk to the cloud. You also need to register it with a voice product, because this is going to be a voice-enabled device. So how do you do that? You have to create a voice product with Alexa voice service, and you also have to specify the AWS account number, because remember, this is the AVS integration for IoT Core capability we're talking about. That's why you need a AWS account or set of accounts where these devices are supposed to communicate with. So think of this account as, if you're a device maker, this is your cloud, and you are managing all this connectivity back to the Alexa voice service. So this is pretty important for you to understand that once the IoT devices are connected, you also need to associate with a voice product. And once that is done, then your fleet can start to talk to Alexa IoT service and the Alexa voice service at the back end. So this has essentially three different components, right, to summarize. The first one is the embedded application code that goes on to this device, which is running Amazon FreeRTOS, which is, again, a microcontroller operating system. And this application code has to be developed by you, because you know what your light bulbs should do or what your switches should do. You might have a smart light which has a lot of dimming capabilities. You might bring other capabilities as well. So all those business logic essentially goes into your application code, and you take all this application code, you take all the keys and certificates that you generated earlier, you take all the security profile that you created with the AVS console that you saw in the last screen, and then finally you flash it onto this device. And now it will be packaged and it will be made available in the consumer market for me and other people to buy. Okay, so now when I get the device as a consumer, let's say I buy this iDevice switch, then the first step I need to do, I need to open up the companion app, and I have to register this with my Amazon account. It's similar to any Amazon device that you buy. And once that initial authentication is successful and the device is now in my account, after that, everything is seamless to you, just like an Echo product today. But the way it works under the hood is all the communication, even the audio communications, are now going over MQTT topics to AWS IoT Core, which is your account, and you are the device maker here. And from there, it uses Alexa voice service APIs at the back end. Make sense? Okay, so now you have manufactured all these devices, which is pretty cool. All these devices are on the field. People are buying it, and they're loving it. So how do you ensure that you keep the experience great throughout the life cycle of the thing? If I'm buying a smart switch, I want it to improve over time. It should not be like this dump switch that I have at home today. So how can you do that? So let's see. But before we go there, let's also talk a little bit about security, because security is a top priority for us at AWS, and whatever we do, we start with security. So firstly, all these device to cloud communications are encrypted through TLS. There we follow the AES GCM cipher suit, and there is a shared key that you created earlier, which is only available with the device, and only the device should have one key and a unique identity to communicate back to the IoT cloud in the AWS account that is being provided by you as the device maker. Also, when the communication happens, there is a reserved topic namespace where all the messages are going in an encrypted way. So no one has even the access to subscribe to these topics and listen into the data. So there are two different kind of topics that we have. One is the control topic, which is essentially the control plane, and there is also the data topic, which is the data plane. In the control plane, the connection topic is required to establish the session first time between the device and the cloud, and there is a session identifier, which helps them to communicate henceforth. There is a capabilities topic, which helps the device to configure different kind of capabilities, like it could be the buffer size, it could be the bit rate, it could be the format. So currently we support only Opus, as I mentioned earlier, but in the future, you never know, we might support other formats as well. And you have the control to specify what kind of configurations and what kind of formats that you'd like to choose. There is also this events and directives, which handles all the requests and responses coming to the AVS cloud. Now, the data topics, which are highlighted in blue, are the microphone topic, which handles all the user interaction data. So when I say, Alexa, play Baby Shark and whatever, it's essentially all this user interaction data being sent through the microphone topic. And also the speaker topic. So when Alexa plays a music for me, it uses a speaker topic. And you can see that some of these boxes are highlighted in yellow, which means all the data are encrypted through TLS again. There is one other important concept that you should know, that with AWS IoT Core, we support two quality of services today. One is cause 0. That means the messages can be delivered 0 or more times, or cause 1. That means the messages will be delivered at least once. But in both of these cases, the order is not guaranteed. So to ensure that there is proper ordering to your request, there is also the logic that is built in on the client side, so messages could be processed in order by both the client and the server, and that requires some buffering and sequencing as well. Okay, so now let's say you are the consumer and you would like to find all the different light bulbs, which is a firmware version 1, because now you have a firmware version 2 that you want to deploy over the air. So how do you do that? So you will have all these devices now registered with IoT device registry. When you have done that whole provisioning workflow, all these devices are automatically registered in the device registry. And then also IoT Core gives you the option to index your fleet. It uses a Lucene-like engine under the hood that indexes different kinds of data. It could be the metadata, the shadow data, the connectivity data, and then you can run search queries on it, like find all the thing names which has a light on it, which are currently connected, and which is a firmware version 1. And once you know that, you can then also use that for different other purposes that I'll come to. But how does the device registry look? So in device registry is provided to you by a service called IoT Device Management. This is where you can organize your devices. It could be static groups. So you might have your devices segregated by location, like the geo, by demand, and by risk. Also, you might have it by product type. Like you might have light bulbs for the home industry. You might have light bulbs for the industrial customers as well. So it's up to you how you create all these different groups and associate your light bulbs and switches, but we give you that tool and flexibility to do that. And once you have done that, you can start doing searching, as you see the query in the last slide, on all these different kind of devices with different kind of attributes and parameters. So now you have identified all these lights with the firmware version 1. You would like to push the V2 to all these devices, all these light bulbs and switches. So to do that, you create a over-the-air update for all the group of devices that you can choose in the registry. It's up to you how you want to patch them. And then the OTA update service essentially creates an AWS IoT job to notify your devices that an update is available. So on the device firmware, you have to include the Amazon FreeRTOS over-the-air agent library for that to happen. And your application now is subscribed to the respective MQTT topics on the device. They receive the job document. It's binary blocks, so they have to reassemble them. They have to check the digital signature and finally install it. So this is how it actually works under the hood. You can see there's a lot of communication happening between the device and the MQTT topics, which are essentially reserved for this purpose. And it's a best practice, to digitally sign and encrypt the firmware prior to deploying to a device or a group of devices, because code signing ensures that the devices only run code from trusted authorities and that the code has not been altered or corrupted since it was signed. And it also helps because you now can reduce the EBOM cost by patching your devices throughout its entire life cycle rather than shipping new devices every few years. So the life cycle of your device is now also extended because you can update it over the air. Just like your iPhones and everything else, all these smaller devices now can also be updated over the air, which is pretty cool. So now my mom is happy. She can directly talk to the switch. I have one of this. And the speech utterance will go to Alexa voice service and the respective skill gets invoked. For me, it's Philips Hue. And the skill will essentially update something we refer to as IoT shadow, which is essentially the state of the device, which turns the lights on. So one interesting thing is, even though it's running microcontroller, it does not impact the skills that you can run. It's same like the Echo family. You can build your own custom skills. You can use all the third-party skills that is already available in the Alexa skill store. So nothing changes in terms of the experience. But how does it work? So when we say that Alexa turn on the light, turn off the light, and I said it uses device shadow, but what it actually means, the way it works is, again, it uses a set of reserved topics under the hood, which is required by the IoT shadow service to receive all the different messages coming from the devices, and then it processes the messages, and it sends back to the respective device, the respective command, which is turning off or turning on, and the device then do whatever it needs to do. And for this to happen, you also need to have the shadow library. There is an Amazon FreeRTOS library for that, and you need to ensure that you are using that shadow library so that you can process all these messages on the device side as well. There's another thing that you need to know for shadow is because we have built this service for you, we also do a lot of versioning in terms of ordering of the messages. So if you say turn on the light, turn off the light, again turn on the light, the device shadow has a version control which will ensure that your messages are also ordered as it sends back to the device. Okay, so now you understood all of this. We talked about Alexa voice services. We talked about Alexa IoT service, some of them, the FreeRTOS, IoT Core, and device management. And now I want to show you how we put all of this together. Okay, so you have the Alexa built-in device on the left. This is where you have the speaker and the microphone and the device SDK that you need to put, that we discussed. And then on the cloud side, it communicates over MQTT to AWS IoT Core. So there is a voice that is going through Alexa voice service. Then there is all this data, which is the device data, metadata, that is in the device registry because all these devices are provisioned. The IoT shadow capability so that you can interact with the device, and there might be some use cases where you need to invoke Lambda functions as well if your skill needs so. Now, once the devices are on the device registry, use device management, IoT device management, where you can send all these firmwares, new firmwares over the air using IoT jobs. You also have the option to use something like Device Defender, which ensures that the health of your fleet is secure through its life cycle. So you can do a lot of auditing, you can detect anomalies in real time, and that is integrated with many other services like Amazon SNS. And there could be many other IoT services that you can bring into the play. We did not talk much about the data layer, so that's where you have the telemetry and the events and operational data, and you can use other services as well in conjunction to this reference architecture like IoT events and others. So only thing that stops you is your imagination and the use case that you have. So now pricing. So all these reserved MQTT topics that we talked about earlier that is being used for the voice is not being metered to you. That means you do not pay for any of this. You only pay when you use additional IoT core functionalities like the IoT jobs, the IoT shadow, and all the stuff. So you can refer to the pricing at the link here for more details. So now the obvious question is, okay, all these things looks cool. How do I get started? So today we are partnered with two of the silicon chip providers. One is NXP. So they have built this device already that is available for purchase. There is a link over there, the small bit.ly link where you can go and you can purchase one of these devices. This is essentially running FreeRTOS. And this has the Alexa wake word engine, It has the far field audio algorithm, and if you can see on my screen, this is essentially the NXP device that I'm going to use for the demo. We have also partnered with Qualcomm. They have also created a similar device which supports all these cool capabilities, and it's also running Amazon FreeRTOS. And we are working with many other partners, so you will see more and more devices which are Alexa built in and which have microcontrollers using FreeRTOS. And in terms of resources, if you want to get started once you have purchased those kits, these are some of the getting started guides that you can refer to, and this will help you to build your next cool voice product. So before I let you go, I have one more thing for you, and that is the demo. So this is an NXP kit, which essentially being used in a miniature version in this iDevice switch that you saw before. So you saw that how I talked to the switch and it did whatever it had to do. Now I will show you how to use the device that is essentially inside the switch to do something similar. But before I do that, I also want to show you what happens under the hood. So this is the backend to these devices. I have connected to it over a serial interface, and when I talk to this device using the voice commands, you will see all the communications are going over through this log. And it is going to the cloud, and the response is being received. And then you'll also notice the latency of getting the responses back. So, Alexa, what is the time?
It's 11:26 a.m. Happy Friday.
Alexa, set volume to 10. Alexa, what is the time?
It's 11:26 a.m.
So you can see continuously in the logs that whatever I'm talking, all these messages are being streamed from the device back to the cloud, and it's being received back. And this is using all the architecture that we talked about. The Alexa voice service APIs is using the client SDK running on a microcontroller, but still the experience is great, right? So now let's see if this one can play Baby Shark for us. Alexa, play Baby Shark.
Baby Shark by Pink Flown, starting now on Amazon Music.
Yeah, awesome, right? And you can see all these messages are going over MQTT. So generally, Alexa, stop. So generally, MQTT is considered not so great for audio messages, but you can see it might not be great, but it's pretty workable, and you cannot notice the difference compared to other Echo built-in devices which are larger as well. So again, kudos to our engineering team. They did an incredible job to make this happen. So now let's go back to the console, and you can see that there is this thing which starts with SSN. Let me make it a little bigger, which is essentially the device representing this NXP kit. Now, when you do that whole provisioning that we talked about, it will create a thing like this into the device registry. And now if you go into the thing, you will see that this is a certificate. So these are the certificates that will get provisioned, and this goes back to the devices, which ensures that the communication is TLS encrypted. There is also a thing group. So this is where you have you can create multiple parent groups and child groups. So for me, I have just created the light bulbs as one of the thing groups, and you can have hundreds of things that can be assigned to all the static groups. And there is also a concept of dynamic group. Then you have the device shadow. So whenever we say this device to turn on the light or turn off the light, the shadow essentially stores the state of the devices. So you can see that there is a status of on, or there could be other attributes that you want the shadow document to store. So the next thing I want to show you is, let's say you have these devices, and now you need to search for these devices. So you can search with the attribute version. So we talked about how you can find devices which has a firmware of version v1. And once you have found these devices, you can see the serial number, you can see the version v1. You know these are the things that needs to be patched. And then you can go to AWS IoT Jobs, and then you can essentially push an over-the-air update to all these devices as well, which is pretty cool. And now, since all these things are in the device registry, you can do a lot of other stuff. We talked about Device Defender a little bit. So you can essentially do a lot of auditing. You can, detect anomalies in real time. You can create different kind of security profiles and violations. So for the interest of time, I cannot go into all these details today, but essentially, since your device in the device registry now with IoT Core, you have the opportunity to use all these additional IoT services to make your workload more secure, more manageable, and more organized. So that being said, a long presentation. So Alexa, tell us a joke.
Why did the wizard get a job as a cook? Because he was good at sorcery.
See, all the messages are again going back in that loop with all the directives and events coming back. So this is great. We covered a lot of stuff. So to summarize, what did we cover? We started with a quick overview of Alexa voice services, and we talked about how it works under the hood today. We talked about the Alexa voice service architecture. We talked about the device architecture. We talked about different experiences with Alexa, with far-field and with tap to talk. With some works with Alexa, some has Alexa built in, and then I introduced to you the new capability, which is building Alexa devices on top of microcontrollers, which I hoped you liked it. I like it a lot. And then you learn how all these voice control devices are like any other IoT devices, end of the day. And you can use all these different IoT services to manage them throughout their entire life cycle. You also got a pick of a quick reference architecture. You have access to a getting started guide, and you saw a quick demo as well. So now, before I let you go, I have to probably tell you this. I told you that, about my mom, how she would like to talk to the switch, and she can do it now. But she is very careful of how she uses her resources. So I noticed that she never uses Alexa later at night. And one day I asked her that, why don't you talk to Echo to turn off the lights at night? And she said, it's 10 p.m. and she must have gone home. Thank you.